David Cadillo, reporting from DLSD News. Earlier today, two students from our school were able to find out our canteen's height only using their trigonometry skills. Let's check with our news anchor, Mick Olanday, for more info. Mick?
Thank you, David. I'm here today with Anton Apostol and Luis Salvador, the two students who found the canteen's height building with only using their trigonometry skills. Now let's go to them. Hi, Anton. Hi, Luis.
It's a pleasure.
So tell us more on how you found the canteen's height.
So basically how we did that was to use the clinometer app on my iPad, which lets you figure out the angle according to how you look or how you tilt your device, like so. So in this case, you would use it like a sight. You have to look at the highest point of the building, like so. You have to look at the highest part of the building, and here we got an approximate angle of 47.5 degrees. So after we measured our 47.5 degree angle looking at the top of the building, we drew it on a diagram. So Anton drew this. This is a canteen building, and this is me. So as you can see, we measured 47.5 degrees. So there it is, looking up. And our distance was about 7 meters. It's not very clear, but it's right here. It's 7 meters. So using those measurements, you can form a right triangle like so. You have the 7 meters here, you have your angle of elevation here, hypotenuse, and you have a 90-degree angle here too. So to get the height of the building, you need to know what this x is, and you need to add 1.5 to it because that's the excess distance below my eyesight. So in order to do that, you have to get x first. So to get x, what you do is use SOHCAHTOA. So SOHCAHTOA basically is something that you use when you're solving for right triangles that has to do with sine, cosine, tangent. So O stands for opposite, A stands for adjacent, H stands for hypotenuse. In this case, we have the adjacent and the opposite, so we're going to use TOA. So that would mean tangent 47.5 degrees equals opposite, which is x, over adjacent, which is 7 meters. And when you solve for that in the calculator, your x would be approximately equal to, as you can see here, tangent 47.5 times 7. You get about 7.64 because we have to round off to the first two decimal places. So you get 7.64 meters. And once you have that, all you have to do is to add 7.64 to 1.5 meters. And let me show it here. Plus 1.5. You would get approximately 9.14 meters. So therefore, that is the height, the approximate height of our canteen building. It's 9.14 meters. And it's only approximate. Obviously, if you want an exact measurement, you'd have to measure. You'd have to use a real ruler, but that's approximate using your distance and an angle of your elevation looking up.
So basically what Luis did was to figure out of the building's height using trigonometric ideas. And in trigonometry, what we do is to analyze and solve for triangles measurements. Since the diagram formed a triangle, he was able to solve for the approximate height using the distance, 7 meters, and the angle of elevation he got was 47.5 degrees. Once he had the height, he just added for 1.5 extra meters below him, and there you have it.
So basically, just like what Anton said, you can use trigonometry for lots of things. Commonly, you use it in estimating height of buildings, like what we did here today. But honestly, you can use trigonometry in more ways than one. You can use it if you're an architect. If you're planning to design a lot and at some point you need to know the angles, or if you're doing a big triangular lot, then that's the point where you really need all your sine, cosine functions and your angle knowledge to come into play. If you know lots of trigonometry, you'd be able to solve accurately the angles of your lot, the side lengths of each wall that you're gonna build, and all kind of things like those. Also, if you're going to be a ship captain or a pilot, you would know how to navigate your ship properly and safely because you would know the angles that you use in directions. since in these things you're basically using angles as your directions. Let's say you're a pilot and you're told to fly north 40 degrees west, then you know where to turn your plane towards. Or if you're a ship captain and your course is south 15 degrees west, then you know where to turn your ship. Basically, if you know your angles, if you know your directions too, it's gonna save your life. Think Titanic.
Thank you guys, that was very interesting and informative to our students and viewers. Thank you both for your time, Anton, Luis. Back to you, David.
Thank you, Mick. That was DLSE News. Until next time.